Okay, all right. So we just did a quick quiz on 15-minute quiz on these three questions here. Suleiman, if you're listening to this, you should pause it right here, spend 15 minutes, do these three questions, see how far you get, and then come back to the recording. Okay, but I will go through the answer now. All right, so first question, so 16A, question 13. Okay, let me draw a line here. So once you guys have done these questions, I picked the ones that are actually not too difficult if you know what to do. So have a look, question 13. The life of a type of light bulb has these ones and evaluate K. So what does it mean by evaluate K? Sorry?
Find K.
Is to find K, correct? And what's the idea here? What makes a function a PDF?
Equals to 1.
What equals to 1?
Area.
Yes, the total area, right? Total area equals to 1. Which means for question A, I know that I have to antiderive from, so the start is 1000 and the end is infinity. But remember, you can't antiderive to infinity. You need to use the letter A and then you calculate limit of A to infinity. Okay, and then antideriving this value must be equals to 1. Okay, because the total area must be equals to 1. All right, so let's antiderive that. So that will be, once again, that would be lim of A to infinity, antiderive 1000 to A, and then I'll just take the K out. You can, K is a constant factor, so you can take it all the way out to the front here. Okay, you can take it all the way out to the front. And then that would be x to the power minus 2, dx equals 1. All right, let's see. So then we've got K times into the lim expression. All right, and then this one would be plus 1. So that's minus 1 divided by, that's a negative of x power minus 1. 1000 to A equals 1. Okay, let's see. So then that would be K times the limit of A to infinity of, you sub the values in. So then that would be, so note that minus x power minus 1 is minus 1 over x. Okay, so the power negative 1 is just 1 over x. So then that would be minus 1 over A, and then minus minus is a plus 1 over 1000 equals 1. Okay, and as A goes to infinity, what happens to this term here?
It's going to 0.
It goes to 0, that's right, which means the next line is K times by, and then that would be 0 plus 1 over 1000 equals 1. Okay?
K over 1000.
Yep. Hello? Spam. Alright, thought it was Suleiman. Okay, so that would be K times 1 over 1000 equals to 1, and then K would just be 1000. Okay, so that's how you find K. Rings a bell? Yeah, okay. As I said, it's just antideriving to infinity, right? And then the theory of dealing with proving something is a PDF, which is total area equals to 1. So question B, now find the probability that a bulb will last at least 2000 hours. So I can do the derivative again, I can do to infinity again, but there is an easier way. All right. Probability x is more than 2000. There is an easier way to do this, which is 1 minus the probability of 1000 less than x less than 2000. Does it make sense? Yeah, because the total area is 1. All right. So more than 2000 means 1 minus the area from 1000 to 2000, and 1000 is just a start. Okay. So this is the easier way of doing this question B here. All right. So then that would be 1 minus, and then this is just now an easy antiderive, right? 1000 to 2000 of, now we know what K is, that's just 1000 over x squared dx. And that would be, take the 1000 out, 1 minus, and then we already did the antiderivative before, which is that expression there, the minus x to the power minus 1. So I'll just cheat a little bit, rewrite that here. That's minus 1 over x, calculated from 1000 to 2000. Okay, and right, and then there's a K at the front as well, so that will be 1000 at the front. Okay, so then that would be 1 minus 1000 times into, you sub 2000 first, so that's negative 1 over 2000, and then plus 1 over 1000. Okay, and now I can multiply the 1000 into each of the term in the brackets, and that would be 1 minus, so that would be minus 1 over 2 plus 1. Okay, expanding the brackets will be 1 plus 1 over 2 minus 1, which is 1/2. So the probability that x takes is more than 2000 is just a half. That means what's the meaning of the number 2000? So this is not in the question, but what do you think is the meaning of the value 2000 here?
Median.
Yes, perfect. That is the median. Well done. So in this one, they're saying that at 1000 onward, right? It is e to the k to the power negative x. So it looks I think it looks something like 1 over x squared. So the smaller is higher. Okay, yep. So it looks something like 1000, that's 1. So that's like this. Okay. So we'll keep approaching the x-axis. All right. And what they're saying is the value 2000 will split the area into two halves, two equal halves, right? So the area here is 0.5 and then the area here is 0.5, which means yes, Sahar was very, very correct. 2000 is also equals to the median. Okay, so this is not part of this question, but I just want you guys to know how to interpret these values. Okay, make sense? Yeah. Okay. Next would be question 17. Okay, I'll be honest, this one is a little bit trickier because it has a conditional probability, but the antiderivative is very simple. Like I picked this question because the function is e to the power minus x. Okay, e to the power minus x is extremely simple. So sketch this graph. We already know how to sketch this one, right? Normally it's like that, and then e to the power minus x just flipped around like that. There is not even a translation. All right, so sub x equals to 0, that would be 1, and then it would just go like that. So simple. That's for question A. Okay, yx. Right, e to the power minus x. You guys did this in unit 3. You should be able to do these exponential graph sketching now. So now question B1. Right, B1, probability of x less than 0.5. Now it means that you go from 0 to 0.5, but remember the little trick. You can go let g of x, so we call that a different function, equals to e to the power minus x. Okay, make sense, Emily? I'm just casting it to a different function, because remember fx is a piecewise function, so big F of x is also supposed to be a piecewise function. You guys haven't learned how to do this one yet. You learn that soon. Okay, in the next few lessons, maybe today, we'll see. So yeah, so we let gx be equals to that, and then we calculate big G of x, so that would be the antiderivative, so that would be minus e to the power minus x. And now we need to calculate g of, okay, so yeah, so probability of x less than 0.5 is the same as antiderived from 0 to 0.5 of the equation, right? E to the power minus x, right? Which is the same as big G of 0.5 minus big G of 0. Okay, so then I just need to calculate big G of 0.5 over here, and that would be minus e to the power negative half. Okay, and then big G of 0 would be minus e to the power 0, which is minus 1. So then this one would just be minus e to the power minus half, and then minus 1, which then would be 1, positive 1 minus e to the power minus half. Okay, this is the answer for question B1.
I made it so it's negative root e. Can you do that?
That's fine. What? Negative 1 over square root e is correct.
Oh no, I didn't do that.
Yeah, it's not just negative square root of e, because let me check what the textbook answer is like. 17, right? Yeah, let's just leave it as it is. But if you want to change it, right, that one there would become 1 over e to the power half, right? Because negative power, and that would be 1 over square root e. Yeah, so another version of this answer would be 1 minus 1 over square root of e. So this is also an okay answer, but it's 1 over. Okay, now B2. So probability x more than 1. So note that x more than 1 is the same as 1 minus what? So probability of x is more than or equals to 1 is equals to 1 minus probability of x is
0.
Yep, 0 less than x less than or equals 1, the area between 0 and 1. Does it make sense? Emily, does it make sense? The area, so they're saying that the total area, right? So the total area, and it goes to infinity, yeah? So the total area of imagine a box is 1, because that's a PDF, right? And then they're asking you at 1, they want you to find the area more than 1, so from 1 to infinity. I mean, you can technically do the 1 to infinity, but if you don't want to deal with infinity, you can just take the total area, which is 1, and then you subtract the area on the left, which is from 0 to 1. Does it make sense? Yeah, so the area from 0 to 1 would just be the remaining. If you know, so the area from 0 to 1, when you subtract that from 1, you get the area from the right, because the total area is 1. It's like 2 boxes. Subtract one of them, basically. Okay, the concept is not difficult. So that's 1 minus big G of 1 minus big G of 0. Note that you make sure you put that into a bracket. Okay, so big G of 1 sub 1 into big G, that would just be negative e to the power minus 1. Yep, and then G of 0, we did that before, that's just negative 1, so plus 1. Okay, so that would be 1 plus e to the power minus 1, and then minus 1, which is e to the power minus 1, or 1 over e. Okay, so that's the probability of x is more than or equals to 1. Okay, any question? No? Okay, next. 17.3, so probability of PR of x more than or equals to 1, given that x is more than 0.5. Okay, using the rule, that would be PR of x is more than or equals to 1 and x is more than 0.5. Okay, over PR of x is more than 0.5. Okay, it's just conditional probability rule. So then, if we were to resolve the conditions, right? So more than or equals to 1 is like this. That line there, and more than 0.5 is this line here. What's the overlapping part? That's the overlapping part, guys.
0.5 to 1.
Nope.
From 1 on.
From 1 onwards. Because it's from 0.5 to 1, this one doesn't cover anything. Right? So from 1 onwards. So that's the same as PR of x is more than or equals to 1 over PR of x is more than 0.5. Okay, and we got, let's see, we got almost all of them. So we got PR of x less than 0.5, right? Which means, so the top, I'll keep that the same, and we got that already. The bottom will be 1 minus PR of x less than 0.5. Okay, does it make sense? That 1 minus thing compared to this. Yeah?
Yeah.
Okay? So again, it's a box when you have 0.5 to the end, right? If you want this section here, it's just 1 minus the other section. Alright? So that's 1 minus PR of x less than 0.5, and now we've got all the values. So PR x more than or equals to 1 is e to the power minus 1 divided by 1 minus, and then I think the other answer was 1 minus e to the power negative half. Now just got to simplify. E to the power minus 1, just put that 1 over e, and then divided by, so let's just write the division. So that'll be 1 minus 1, which is 0, and then plus e to the power minus 1 half. So then that'll be 1 over e, and then divided by 1 over e to the power half, which is then 1 over e times by e power half over 1, and then just simplify these two. That would just be e to the power 1/2 minus 1, which is e to the power minus 1/2. Okay, does it make sense? Any question? No? So how, Emily? All good? Yeah? Okay, so that's the answer for 17. Notably, this one is a little bit harder than the other one, but the last one should be easy. Okay, so the last one is 16b, question 12. Now, this one is a calculator question. How would you solve this one using a calculator? Okay, so this one now is question 6, chapter 16b. Find the expected value mu of x. So what's the expected value formula? Mu equals to? What's the formula here? Equals what? Anyone? Remember? Don't remember? It's very simple. You antiderive from start to end of the only thing that's different. So normally you have the equation, right?
Multiply x.
Yes, you multiply x in it. Okay, so just x times that. And then using graphics calculator, you just punch the whole thing in, and then the answer will be, let's see. You just need to use the definite integral. Okay, actually, you guys grab your graphics calculator, work it out, tell me the answer. And I'll check if the answer is correct. Should be able to calculate this one easily.
I didn't bring my calculator.
Okay. Okay, yeah, like this. Remember to always bring your graphics calculator. There's a high chance that almost every lesson will need it from now on. The more you do probability, the more calculator you actually need to rely on.
This is 0.714.
Yep, 0.714 is the correct answer. That's it. 3 lines. Okay, with the calculator, this is 3 lines. Okay, now question B is a little bit trickier. Let's see. Median value means that, let's say the median value is m, right? That's a median, right? That means you antiderive from the start, which is 0, to the value m of the normal equation without timesing anything in. There's no change to it, right? When you antiderive this, the answer must be nope, median 0.5. Yes, it's half of the area. Yeah, the median is the value that chops the area in half, right? So when you antiderive from the left side to the median, it's half, right? And then when you antiderive from median to the right hand side, it's also half. But I'm going to use the left to median for now. So how do we get this one to the point where we can use a calculator? Well, it's just antiderive it. So take out the 30. Actually, you don't need to even take that out. Just, actually take that. Take out the 30 and then 0 to m times the x power 4 in. So that's x power 4 minus x power 5. dx equals 0.5. And then 30 from 0 to m of, at this point we can antiderive. So that would be x power 5 over 5 minus x power 6 over 6 from 0 to m equals 0.5. Okay, now I want to times, because divide by 5 and divide by 6 are both factors of 30. So I'll just times the 30 in to simplify each of them. Yeah, so now I will times the 30 into each of them, and that will be 6 x power 5 minus 5 x power 6. Any question here? No, Emily? No? Okay, so then you substitute in m and 0. Sub 0 is just 0, so that would just be 6, and then that will be 0.5 at the end there. 6m power 5 minus 5m power 6 equals 0.5. Bring the 0.5 over, that one just repeat, minus 0.5 equals to 0. Using GC, m equals to, alright, and now work it out. And then what is calculator. Yeah, so what's the function for this? And solve, yes.
Is it 2.735?
Not 0.735. Be very careful with your rounding. M is 0.73555, which rounds to 3 decimal places as 0. Yes, 736 to 3 decimal places. Yeah, be careful with your rounding of numbers. Did you get that one, Sal? Yeah. Okay, that is it. All right, does it make sense now? Yeah. So 16A and B are very important. All right, you will get a question from these two chapters. I guarantee 100% you will get a question from these chapters in the exam. 100%. I've never seen an exam that don't have these kinds of concepts. The minimum you get is the probability of like, oh, what's PR of X more than something, and then you antiderive from 2 values. That's the minimum you would get. Okay, so the ones that from the quiz today are a little bit harder, which test you on more concepts. One is the proof of PDF, total area equals 1, right? That's question 13. Question 7, and then also question 13B also tests you on antideriving to infinity, which you might get. And if you do, I want you to be able to do that question fully in the exam. Okay, we'll do more practice later and closer to the exam. But yeah, so question 17 is about the main thing. So sketching is normal, but then the main thing is actually just finding probability. Okay, and the idea of 1 minus the other side. If you want the right hand side, the area will just be 1 minus the left hand side. Okay, so this one is, let's just say you have a box, right? On the right hand side is infinity, on the left hand side is 0. So you want the right hand side. So right hand side is the same as total probability minus the left hand side. That's it. Okay, so keep this concept in mind. It will come in very, very handy. If there's any question you're like, oh, I have no idea what to do, how do I do this? Think, oh wait, can I do the 1 minus? Can I use 1 minus rule? Because sometimes it makes things a lot easier. And in the exam, it's a very important technique. Okay, and 17 also tests you on another one, which is conditional probability. There is a chance it will come out. There's a chance it won't, but it's better to test this to just actually conditional probability may or may not come out for this chapter, but it will come out in the exam. There are a few other chapters in the future that it will also use conditional probability. Remember the chapter 15AB? Yeah, what's the chance you're getting 6 successes given you have more than 5 successes? Remember that one? Yeah, conditional probability. It will definitely come out. Okay, conditional probability will definitely come out. I just don't know which chapter it will come out. But most likely it will come out in one of the chapters because it's so easy to ask and test so many things. Okay, now 16B is just testing how to use a calculator. So just testing you 2 main concepts. What is the expected value? And you guys forgot that. It's just antiderive of the start left to right, but you have to times x into it, into the function before you antiderive. Okay, that's the main one. So the formula for this, mu is antiderive left, so negative infinity to positive infinity of x times into the function fx. Okay, the new thing is that you gotta times x into it. That's it. And median is the idea that when you antiderive from the left to the median, the area is how?
0.
Yes, 0.5, not 1. Yeah. Okay, that is it for this diagnostic quiz. I just want you guys to revise on these 2 concepts. Let's take a short break and then we'll move on with chapter 16C, measures of spread next. Alright, give out the sheet first, and then I'll stop the recording. Suleiman, please continue with the second recording right after this. It's only been like 20 minutes of study.